Hello everyone, my name is Wang. I'm from Nanjing Hydraulic Research Institute. Firstly, I want to thank this opportunity of Best Researcher Award in International Research Awards of Mechanics of Vocational Materials and Structures. Now I want to share the topic development of high-strength gypnum motor based on fly issues like correlational analysis of microstructure and mechanical properties and environmental assessment. My report is mainly divided into 5 parts. The first is research background and significance. Facing the severe challenge of global climate change reducing carbon dioxide emissions in the construction industry has emerged as an urgent global necessity. Therefore, under the dual charge of environmental protection and climate change, developing new and suitable building materials for the construction industry, especially finding alternatives to ordinary Portland cement to reduce carbon dioxide emissions during the production of building materials has become a focus of current research. Gypsum mortar, as an innovative type of building material, has gradually become an effective substitute for cement due to its low carbon dioxide emissions and strong environmental adaptability. It shows great potential for application in various fields such as construction, civil engineering, and transportation. However, current research primarily focuses on the mechanical properties and durability of normal strength gypsum mortar. There is relatively less research on gypsum mortar that meets specific high-strength requirements, which limits their application in high-rise buildings, large span bridges, and complex structures. Given the escalating demand for building materials with high performance in modern structural engineering, particularly those seeking greater strength and durability. Pushing research on high-strength gypsum mortar is of paramount importance. Therefore, this research aims to develop new suitable materials that meet the high-strength requirements of model engineering by delving into and optimizing the formulation and preparation of processes of gypsum mortar, which provides a supplement to exciting research. The second is research content and experimental design. This study designed 5 different of gypsum mortar max properties use a controlled variable method with slag content as a key variable while keeping other parameters consistent with specific parameters shown in table. Due to the complexity of the composition of gypsum mortar, merely conducting traditional snap tests is no longer sufficient to characterize the workability of gypsum mortar. Rheology refers to the deformation and flow of materials under external forces, revealing the relationship between the deformation of gypsum mortar materials and rheological parameters. Shear stress is one of the rheological parameters which is considered to be the friction between the fluid and its moving boundary and indicates the force required for fluid shearing. Therefore, it's necessary to start with the rheological characteristics and the models of motor. Study on the interactions among the components within the motor and thus fully and accurately grasp the complexity workability of fresh motor. Finally, the mechanical properties and the microstructural properties were tested. The third is results and discussion. The relationship between the shear stress and the apparent viscosity of motor and their corresponding shear rates is demoed in figure. The figure illustrates the effect of slag content on the mechanical properties. Compressive strength, flexural strength of motor at different target ages, overall increasing the slag content effectively enhance the mechanical properties of motor. Notably, the trends in changes for compressive and flexural strengths are slightly different. The DTG curves further demonstrate the differences in the types and quantities of hydrogen products at various decomposition temperatures. With relevant test results presented in figure. The figure presents the MIP test results of samples with different slag contents, where the A shows the cumulative mercury intrusion curves and the differential per diameter distribution curves. The figure shows the influence of slag content on the per volume distribution in motor. Based on the results in figure, it's observed that as the slag content increases, the cumulative mercury intrusion volume in motor samples consistently decreases, which is highly negatively corrected with the improvement in mechanical properties, especially. This is mainly because excessive slag content can lead to too rapid polymerization processes, making it difficult for some pressure materials to participate in the polymerization reaction in time, thereby generating certain large capillary pores. The fourth is correlational analysis based on correlational degree. Considering the complexity of the effects of reaction products and post-structures on the mechanical properties of motor, the Green relational analysis method is used to analyze the correlation between microstructure and macroscopic mechanical properties. The finale is conclusions. First, high-strength motor preparation method. Adjusting the slag content can significantly enhance the mechanical properties of motor. producing a high-strength gypnum motor when the slag content reducing percent fifths, the comprehensive strength of gypnum motor can achieve a maxi value of. However, excessive high-strength, high slag content can adversely affect the working performance of gypnum motor, reducing in increased yield stress and plastic viscosity. The second, microstructure mechanism of action. The addition of slag not only promotes the formation of key gel products such as CESH and CSH within gypnum motor, but also improves the pore size distribution and reduce the total porosity, thereby significantly enhance the comprehensive strength of gypnum motor. The third, the gray relational analysis method has been proven effective in illustrating the correlations between microstructure attributes and microscopic mechanical properties. A higher correlation with mechanical strength and has been found in the content of reaction products compared to traditional pore structure parameters. Notably, the bond water content in specific temperature ranges has been closely correlated with mechanical strength, shown casting the anti-utilities of the analytical method in understanding material behavior. The fourth, environmental and economic advantages. Substantially benefits in reducing carbon dioxide emissions and lowering production costs compared to traditional Portland cement-based materials have been demonstrated by the high-strength gypnum motor developed, particularly at 5% slag content. The most significant environmental and economical advantages for exhibit, marking a step forward in sustainable construction materials. That's all. Thank you.